Hi everyone, Nganganga Roya here, ready to grace you with another video. So let's jump right in and start learning. So in this video or this tutorial, we're going to learn how to create a simple machine learning predictor model using scikit-learn. This model works like this. It takes a couple of parameters. When you look at this function, it takes bank cases, it takes area, and it takes population. So for example, we can give it bank cases, 100 bank cases. We can give it a population of an area of 250 kilometers squared, and an area and a population of 300,000 people. And when we run this, it tells us 100 marijuana possession cases in a 250 kilometer square radius with a population of 300,000 people leads to 1,152 total crime cases. So it basically takes all these parameters and tells us how many crimes are likely to be there if those parameters are met. We will learn from beginning to end how this model works and how it was created, how I created it. So open your favorite Python IDE. I will be using Jupyter Notebook myself, and let's look at the code. Be sure to pause the video anytime you want to rectify anything and ask any questions in the comment section. You'll also find the source code of this specific code on my GitHub repository, which I will link the description on the video. The data used was obtained from two sources, which is Wikipedia and the Kenya Police Report on Crime Statistics, which is found on their website. Remember, there's a small hitch, and the hitch is that the lack of enough data on the Kenya Police website led to this data model not having this specific model not having a training phase. Hence the prediction accuracy could not be determined. Apologies for that, but let's because usually the models has a training phase, and check how it works with the data, with already determined data, then putting it to work after you have trained it and using it on now data that you want to predict with. But no problem, just make sure you watch also till the end, because as you can see here, the parameters that were used are bank cases, area in kilometers squared, and population. But the beginning I had decided just to use the bank cases alone, and then I decided to change it to accommodate all these parameters. Okay, make sure you watch to the end, and see you in the tutorial itself. Okay, let's begin. So I made this project as a portfolio project. I made it to look like a portfolio project, which you can also use as your portfolio. And I put everything in the Jupyter Notebook. I did the research in the Jupyter Notebook to make the research very easy to carry out, and be able to have this markdown text here that explains a lot of things. So if you read quickly through this, it helps anyone who looks at the project or the portfolio project to see what I did from beginning to end without having to start with the code first, because the code is very, very long, as you can see, and expecting somebody to just go through all the code without explaining what is happening is not fair to them, and it's very hard for you to be noticed as a project. So it starts by saying a research to investigate whether there is a relationship and influence on bank possession cases to crime cases, where bang is basically marijuana. The study was done by Nganganga Roya. It was undertaken in order to research whether there is a relationship and influence of bang possession charges to the total crime cases in Kenya. The information collected also shed some light on the counties with the highest crime rate and bank possession charges per square area and per population size. The packages used are pandas, matplotlib, numpy, seaborn, and scikit-learn. I collected data from Wikipedia and the Kenya police website crime statistics. I cleaned them and merged them together to form a singular data frame, dropping all the unnecessary columns and rows. I then proceeded to making new relevant columns that help me calculate rates, which I used to answer the research objectives, which were: find out the county with the highest crime rate per 100 people and per 10 kilometers squared, and also for the crimes we are interested in this research. The crimes you're going to see them, they are homicide, robbery, stealing. There are 5. You're going to see them as we continue. I will also add them here, so when you're going to check on the source code, you'll find them there. The distribution of bank possession charges per 10,000 people and per 10 kilometers squared, so basically per population size and per unit area, square area. Correlation between bank and crime rate per 10,000 people and per 10 kilometers squared, and also for the crime we are interested in this research, and also to check on influence of bank to crime rate. I used 2022 data since the, I used 2020, sorry. It was 2020 data. I used the 2020 data since the 2019 data did not have drugs. The drugs data separated county-wise. I remember this is something I've written really quick, so it has some mistakes, but when you go to the main source code that I will link in the description, it will be fine. Avoid spelling mistakes, and also I have gone from third person to first person here. These are things that I will change, so I think I'll make it first person all, or just third person throughout. No need to keep on changing from this study was done by Ngangaria to I collected the data, so it will be maybe I did this study, I am Ngangaria and I did this study, I took it in order to research, etc, etc. So the first thing I did data wrangling, collection, cleaning, and transformation. The data wrangling process was done by collecting the data, cleaning it, and transforming it. The packages that I used, as I've said above, were pandas. I imported pandas as PD, Seaborn as NSS. The pandas was just for the data frame manipulation, and SNS, the Seaborn was used from the Seaborn, and matplotlib was used for the visualization. The NumPy was used to convert a couple of data frames to NumPy arrays, so that they prevent errors while running the model, the predictor model by scikit-learn. And then this matplotlib inline was just to make sure the graphs I check appear on the as the output. If I remove this, they will not appear as the output. I'll have to use plt.show every time. But if you're using any other IDE, you have to, after every line of code that involves plotting something, you'll have to write plt.show like that, and it will work. But for Jupyter Notebook, this matplotlib inline works just fine. Okay, I will not write this code step by step because I don't have enough time to do that, but we will go through it thoroughly, and it will be very helpful for you to understand what's going on. So the first step was the importation of the packages. Then the first thing I did was scraping the county population data from Wikipedia. I went to Wikipedia and I looked for county data, and when you just open this up, you'll see that it's a Wikipedia page with some data frames. When you open that up, you'll see it's a Wikipedia page basically with some my internet is having a problem, but when you open this up, you'll see a Wikipedia page with a couple of data frames, and I have written everything here very explainably, very easy to understand. And it says, since the read I used the read-html from pandas to scrape this Wikipedia data. Since the read underscore html functionality in pandas scrapes all the data frames in websites and stores them in a list. Some spelling mistake here. stores them in a list of data frames. I went through all the data frames to identify the one with the county population data. There's some spelling mistakes, don't worry about that. I've written this only once. I have not proofread it, but it's very easy to understand. So what this rich.html does, it goes through all this and saves all the data frames that are here on this website as a list. So all the data frames that are here are stored as a list, and then you have to iterate through all the lists to see which data frame you're looking for. So I stored it as data, so I went through the first list and just checked the head, the two, and this is county of Kenya. Counties are Kenya, Swahili, etc. This is not what we're looking for. Then the second one, which is index 1, there's politics of Kenya. This is not what I was looking for. And then this is the data frame we needed, because it has county, former, area, population 2009, 2019, and the capital. That is good. So we then proceed to storing the data frame as a new variable. We store this as a variable county data, and we can check county data from index 44 onwards. You can see everything, but there's this index 47 which has data that is not helpful to us, because there's already Nairobi County here and there's a lot of null values. So index 47 is not important, so it is dropped. I dropped it and made sure I put in place so that I drop it out of my county data frame, and without putting in place it will just drop it, and then when you check on the county data again it will still be there. So the county data, I drop 47, the index 47, and in place. So when I check again, the index 47 is not there and the data looks really good. Now the next point we have to do is we have now that we have the county data on population and area occupied, we also drop all the unnecessary columns like the population of 2009, the former province and capital. This is not important, this is not important, and the capital is not important. So we drop them. This is how you drop them. You just use the drop, then have the data frames inside axis 1, because the general axis is usually 0. If you check shift tab, you can see the axis is usually 0, and this is the 0 axis. So it will look for in an index that has population here, and it will not find it if you don't have axis 1 here. But if you have axis 1, it will look through the columns for that, and then it will drop that. Have to put in place true so that it drops that, and when we now check on the county head, it does not have all this unnecessary former population in 2009 and capital, and now the data looks good. So save the data to an Excel file called countycrimeresearch.xlsx. I saved it, used the pandas to Excel functionality, and saved it as county_crime_research.xlsx and named it the county data. After doing this, if we can just check on the county data, and now we can see the county data here, and it looks really nice. These are the index, these are the counties, this is the former province. I think I removed the former province. Wait a minute, I think I maybe have the wrong one. Oh, it's county crime data. It's called county crime research. County crime research. County crime research. When you look at county data here, you can see it's very small, looks really nice. I always like leveraging my Excel prowess to help me solve some of these things. And now you can see this looks really nice, perfect. And then when we go back to our code here, we can see the next point now is merging the county population area data to the crime data and drugs data. Okay, the crime and drugs data were obtained from this site here. When you click it, you'll just see the site. Let's give it a moment, which is basically the Kenya police. You can read it here. Let's give it a moment. Is the National Police government.ke crime statistics. So I used the 2021 because the 2019 one has not segregated the drugs data according to counties. It's just given us a general report, which is not necessary for us. We need it segregated so that we can have how the counties are and how the drug data is. Okay. So it is, as I've said, it was in PDF form and data had to be converted to an Excel file. I basically used one of the to Excel tools that there are so many in the internet. To Excel, sorry, PDF to Excel. This is the link here. Sorry, I used this one. I love PDF. And this is the link, and make sure I put it here. It is, I can just add it here. Just say on this site. This is just markdown. This is not that complicated. Let me just put it here. Put the website inside there, enter, and then now this site, when you click it, will just bring you directly to this. I just drag the PDF. This PDF, once you download it, it's called this one. When you download it, it's called NPS Annual Report 2020, and just drop it here. And then once you drop it there, you have a good the data will be converted to an Excel file, which will look something like this. There will be so many tables because it will convert every single table. There are so many tables on that report, but the one that we are interested in is this one. Just reduce the size a little bit. This one, which has the homicide, the crimes. These are the crimes, and then the grand total here, and the counties themselves. And then when you look at 14 here, there's this other one that has the drugs and psychotropic substances arrested for the year 2020. Perfect. And this one is very easy to look at, very easy to look at, because it has the counties here and the crime here. The problem with this one is that it has the counties all scrambled up with the type of drug being everywhere. So for this, you'll have to use a pivot chart, pivot table, to be able to separate it, or just use a pivot table. Just insert, and then you can insert a pivot table that will look something like this. And then you'll just have the type of drug as the column, and then the row will be the county or information. This is the county information will be on our row, and then the columns will be this type of drugs. And then when you just convert them, since I used sum of possession, I'll use the values as sum of possession, and then it will have something like this that looks like this. You can also do a pivot chart on pandas, which is also very easy, and then you can just transport it to Excel. Then you'll have this same thing. I then arrange this in alphabetical order, and then I put the county codes here, and then I just copied everything. This is part of just the transformation process, and then I copied everything here. Just copied all this. I just what I did here, you might not know, I put this in alphabetical order, then they put the codes here. I got the codes in their order from just this. You can just use this. Sorry, you can just use for example this. You can see these are the counties, and these are the codes from 1 to 47, and you can just arrange this in alphabetical order. sort from A to Z, sort. Okay, no problem. We can just take this, copy it, transport it to a new Excel file. The only reason we are doing this, we can just call this county, then this code, and then we can just filter this A to Z. Just create a filter there, come here, filter it from A to Z, no problem. And then now it is filtered the way we want. Okay, you can just format this autofill, perfect. And now these codes are in alphabetical order. We can just copy this, go back to our table here, and then paste it here. And then now we have this according to them, to the how they are. So if we just take this, all this information, let's take it from the top. Just take it from here, copy this, and now we have all the drugs perfectly on the top row, and the bottom row has the names of the counties, and we also have the codes. And then we as you can see here, all the necessary extracted tables were cleaned and stored in a new sheet inside the county crime research.xlsx. So here is where we came and just dropped that that table that we had. We just dropped it here, this table. Then we just arrange this in order, just arranged it in order like the one that you can see. It's just the same thing, bang, brown sugar, etc. Then arrange this in order from 1 to 47. So Mombasa, Kwale, Kilifi, just change this. That's just the same thing. Just paste it here and arrange this in order. Rename this to counties and rename this space here to county code, and then we are good to go. Something else I can do, I can just make sure I format this and autofill the width so that you can see everything, and this is how it looks. Perfect. So the next step is the sheets were named crime data to the for the crime data and drug data for the drugs data. As you can see, drugs data, then there's this crime data that we had, that was, at least this looked good, and it was, everything was fine. And the names, something else that I did, I came and just copy pasted these names these names here so that they are same on all of them. I just paste it here, you paste county here, the names here, and also paste them here so that they look the same. In order, when you're trying to merge them, you'll use this as the key. These names, if they are the same, it will merge very easily. And also arrange them in alphabetical order, just because. As you can see, all the cleaning procedures were done inside Excel, as I've said, and this video of me doing this will be on my YouTube video, which is this video that we're talking about right now, as I've explained right now. Now that we have the data itself, the county data, the crime data, let me just do the same thing here. Now that we have all the data here, the county data, the crime data, and the drug data, we need to combine them together. So we just the crime data, okay, we tell it to read. Now we create a separate variable for the crime data. So the crime data will be Excel reading this county crime research, and then going to the crime data sheet, and then storing this on a new variable. So we create a variable called crime data, and when you look at the variable itself, we'll just see the data from the county's homicide, offenses, other offenses, just like it is on this side. Okay. I also proceeded to changing the name from grand total to grand total crime here. it is grand total, I change it to grand total crime, so that there's a difference between grand total crime and grand total drugs. Okay, that is the crime data. Then we do the same thing for the drug data. We go to this and take the drug information that we have formatted from the what is it called, NPS data. And then we look at the drug data. We can see bang, brown sugar, blah blah blah. There are a lot of null values, and because you're just interested in the bang, all this information is not important. You're just interested in bang, which is marijuana. So all this data was cleaned and given the same county names, merging merging index or key merging could also be used by okay, so this has some spelling mistakes. I really did this really fast, but no problem. So what I am saying here is all this data was cleaned and given the same county name. As I've said, I used the same county name in order to have a very easy merging. We could also use the index, which is the county code, to merge, but you can see this is one. This is does not have the county code itself. It just has the index, and this index for this one is 1.0, and it will just have me clean the data again, make sure they look the same, etc, etc. But having the county names the same, it very easy. Since I have said I like leveraging my Excel skills, to also help me work more efficiently and effectively. So I didn't have to stress a lot in the merging process. And then now I created a data frame where I merged the county data with the crime data, and I called it the data frame. And then this data frame, which has the county data and the crime data, I created a new variable called county info, which merged this data frame, which has county data and crime data, to the drug data, so that we'll have all of them together. This left on and right on used this, as you can see, the county on this county here. It used this county and merged it with this county, looking for information which is the same, and then merging them, and then coming again and using using the county again with the counties here, which is this counties. Which is these counties. Just having a data frame that will use that county and these counties, because as I've said, I use the same name, they combine them together to form that specific data frame. And now the data frame looked like this, and we have everything, the counties and the population and the crime and the drugs. Perfect. Now we proceeded to drop all the extra counties name columns. We also drop the county code that came with the drug data. Now what we are doing here, because we have this county here, we have these counties here, and we also have the counties from the drug data, we just drop this, because we'll just use this one, drop this, drop that other one. And as you can see, it had counties too, the drug data had counties too. And then we also drop this county code, because we have the county code, the code here. So just drop counties, county, and county code, and now the data looks like this. It does not have those extra counties. We look at the columns, county info.columns. You can see all the columns here, and this is how they look. Perfect. I keep on using the column info.column so that I can see the columns themselves. So if I don't remember if it is offense involving police, I just take this and copy and drag it, because it becomes a little bit hectic trying to write it down every time. So as you can see here, since our main drug to investigate is bang, we will drop all the other drugs, and that's why I started with this, so that I can just do it very simply. I want to drop all this. I'll go from brown sugar, where is it? Yeah, grand total bang. I go from brown sugar straight to grand total here, and then I will just basically copy that and then drop it here, give it the curved brackets. Then I say axis 1, as I've said, we need axis 1 so that it knows we want to drop the columns and then in place, so that our data has that in place. Once we drop this, the county info.head, and check on the county info.head and just look on the first 5 rows. We can see it looks really nice because you have the code, the county, the area, population, homicide, all the offenses, then there is bang only here, and that's what we need. We also will not be using all the crime, will not be using all these crimes. We'll just concentrate on homicide, robbery, breaking, stealing, and other offenses against person, because those are the drug crimes that are usually compared or associated with bang or marijuana. So that is the first step. So we drop all the other offenses. This is the code dot drop, then all the offenses. As I've said, I used this. Just select all of them, put them here, and then I just removed from that list. I removed homicide, robbery, breaking, stealing, and other offenses involving person, and then all the rest I deleted them, or I just dropped them and put in place true. And then when we check the head, now we have the code, the county, the area, the population, the homicide, other offenses against person, robbery, breaking, stealing, grand total crime. I also kept the grand total crime so that you can see just the analysis of bang versus crime, and then the bang itself. Now this data frame, as you can see, is very, very small compared to what we had up here, which was extremely long. Here it's extremely long. You can see these dots indicating there are more and more things in between here. Okay, now we have a good small data frame to work with, and now we can proceed to data exploration. Now in the data exploration, as you can see now the data is clean and ready for exploration. In this section, we are going to explore and investigate several things and answer the research objectives, which is finding out the county with the biggest with the highest crime rate, the distribution of bank possession charges per square kilometer and unit or population size, correlation of bank with crime rate, and also this crime that we talked about, the homicide, stealing, breaking in, etc. Checking the influence of bank to crime rate, and this will be the last thing we do. Forget that. The first thing we need to do is to create a crime rate distribution among to check on crime rate distribution among the counties. The first thing we need to do is we will start with crime rate distribution. I'll just call it crime rate per 10,000 people. This will be the first thing that we will look at. Make it mark down. So on this, now we create a new column with the rate per 10,000 people for each crime and for bang. Okay, so the bang one will do the last one. So let me just remove this, create a space there. Okay, so as you can see, I have created a new column called homicide rate per 10,000, other offenses rate per 10,000 people, robbery rate per 10,000, stealing rate per 10,000, breaking rate per 10,000. And then this, what it basically does, it takes robbery divided by the population, multiplied by 10,000. It could have been way easier if I made a variable for this, and then I called it maybe population info, then I just divided by population info, but no problem, so that I don't keep on repeating myself, because it is everywhere. You can see population everywhere. I could have just created a variable and made it very, very easy, which I did for the area, but for this one I did not. But good practice is usually just to create a variable. So now we can see them here. I also created for the total crime, which is grand total crime, and the population here. And then when you look at the county info.head, we can see now we have created new tables here: the homicide rate per 10,000, of or other offense against person per 10,000, robbery rate, stealing rate, breaking rate, and total crime rate, all per 10,000 people. Now we can now see the county with the highest crime rate per 10,000. For example, for robbery, we'll just just write this code where we'll check all the county and the robbery rate, and then we'll sort the values according to the robbery rate in ascending in descending order. So you have ascending equals to false, and we'll just check on the head, and then you can see this Kiambu has the highest robbery rate, and then Lamu, then Taita Taveta with having a robbery case per 1 robbery case per 10,000 people. We now need to create visualization for this crime rate for each crime per 10,000. I just click this again so that I can have all the these columns here, very easy for me to work with, and then create axis for the different graphs. So we have to create the axis. How we need the x and y axis, which will be mapped on a certain graph plot or a certain figure plot. So the y-axis, the x-axis will have the county, and the y-axis will have the rates themselves. So for the x-axis is just the county will take information on the county and the homicide rate, and then it will sort the values according to homicide rate per 10,000 people, and then it will just check make sure ascending is false, meaning if ascending is false, it will be in descending order. Okay, so from the top, from the largest to the smallest, and then we take the head. This last part here is we want to take the county information, and then this here will take the homicide rate information. We'll place them on different axes, and so when we plot them, we'll get the x-axis will have the counties and the y-axis will have the homicide rate. We do this for each and every one of them. As you can see, we'll do this for each and every one of them, putting one variable having the county and the other variable having the rate or the crime rate itself, and we have to do them each and every one of them separately. We cannot use the counties here and the counties as the x-axis here the same as here, because if we do that, we'll have the counties. If we use this and this, we'll have the rates themselves will be good, but the counties will use the order of these counties. So if for example, if we look at robbery, it will take Kiambu, Lamu, Taita Taveta, Machakos, Nairobi, then put it on a graph where this will be on the y-axis and this will be on the x-axis. But this is very specific to robbery rate, because for other rates, maybe Nairobi will be the first one. Sorry, maybe Nairobi will be the first one, then Taita Taveta, etc., and this order is not the same. So we have to create a y-axis, an x-axis for each and one of them, and then we'll do this for all, from robbery to stealing to county to breaking, to breaking, and then to the total crime. Okay, we will now create a figure. This is just matplotlib code where we create a figure and have the axis, and then it's a subplot because we want to put the plots together. We'll have 5 plots because we have 1 2 3 4 5. I wrote this at 5. 1 2 3 4 5 6. We'll have 5 for this top 5. Then the crime rate will have it on its own. So just create 5 of them, call it the homicide rate, call this one the Y label will be homicides per 10,000 people, and then it will use this X as the homicide rate on county and Y as the homicide rate. And then I'll just make it red, make this maroon, make this black, make this purple, make this green, just because. I use plt.show here, but there is no need to use it because we already had the matplotlib in line. This tight layout is just to make it look better. If there are things that are crisscrossing, it looks better. I made the figure 10 by 30 so it looks really good and big. And then we have all the crimes from homicide rate of offense against people, robbery rate, stealing, breaking, and we have them here. I'll just click here so that we can see them, all of them. Sorry. Okay. It's just no problem. A minute. Let me run this. Click here. Perfect. So when you click here, it will show all of them together, but when you click back here, it will just put them inside a small where you can scroll inside there. When you click here, you can see they'll be inside something where you can scroll inside, but I didn't want that. I wanted to see all of them. So you can see homicide rate. Kiambu is Nairobi County is very high, then Nyamira, then Mombasa, then Vihiga. This is homicide rate. Nairobi is number 1, but the difference is not that big because this is about 1.5, this is 3. So the homicide rate though is very high, which is 1.5 extra people are murdered by another person within sorry, this is the wrong graph. You already went past this. It is this one. Yeah, so we are talking about per 10,000 people. So Kiambu per 10,000 people, it has the highest homicide rate with an extra 0.2 of a person, meaning that the big difference between Lamu and Kiambu per 10,000 people is very small, where an extra person is killed in Lamu after 0.2 times 5 is 1. So after 50,000 people is where we have an extra person killed in Kiambu than in Lamu. So this difference is not that big. I hope you have understood that math, because the difference is 0. As you can see, it's like 0.2 because this 1.0, 1.2. So the difference is like 0.2. So 0.2 people per 10,000. So that is 1 person per 50,000. And that is not that big. This is offense against people per 10,000. This is also not that big. Then you can see also robbery is not that big. We can see stealing per 10,000 people. Also, this is not that significantly big, and breaking in is not that big also. Then we can see this is the total. The total what I used the seaborn and made a bar graph which used the axis of the crime versus the axis, and then it gave the data. This is how seaborn code is written. You can just go through your seaborn to understand how this works. Then I set the title as 10 highest crime rates per 10,000 people, and then I just created the figure, because if I remove this, the figure will be really small. You can see it's very small. I just set the dimensions as set a variable here 12 by 6 inches, and then I gave it those dimensions so that it becomes big and very easy to look at. But you can see, as we can see from the above graph, there is no significant separation for the crime rate among the counties. The crime rate is highest, however, in Meru, Lamu, Taita Taveta, and Meru. I'm a little surprised not to see towns like Nairobi or Mombasa or Nakuru here, to be honest, because there is the crime rates there are usually very high. But according to the data itself, the crime rate is not as high as I thought. Then now let's move to crime rate distribution per 10,000 kilometers squared. We do the same thing here, where we create a new column for the crime rate per 10 kilometers squared. Just the same thing using this. As I've said, I used a variable this time, and the good thing about the variable, you can see area here, area here, area here, area info, and the good thing about it is, if I wanted to know per 100 kilometers squared, I just add a 0 there, and then it looks nice. We don't have to keep on going to each and every line of code changing. I'll just change on the top one, sorry for that. Okay, let's just run it what it was, and then we can now see the county with the highest crime rate per 10 kilometers squared. This is not supposed to be there. Per 10 kilometers squared, and you can see that Nairobi has the highest robbery rate per kilometer squared, then Mombasa. Okay, we now need to create visualization for these crime rates. We just do the same thing, create the axis here, You can find all this information on the source code, but you can see we create all the access there. Then we do the same plotting technique using matplotlib, and you can see here like the homicide rate per 10 kilometers is now a little bit different in Nairobi. Nairobi people, there is an extra 1.5 persons killed per kilometer squared compared to Nyamira, which is the number 2. So Nairobi is quite high, because if we go now to 20 kilometers squared, you will find that 3 extra people are killed per 20 kilometers squared between Nyamira and Nairobi, and Nyamira is number 2. So Nairobi is quite high there. This one, there's no big difference between the offense against other person, and then there's in the robbery there's not that big difference. The stealing also not that big of a difference, maybe 1 person. Also this is insignificant in the breaking. And then as we can see from the graphs, homicide in county is well above the rest, while robbery in Kiambu county is also very high compared to the rest, but nothing that significant. Now we create a graph for the 10 highest crime rates per 100 people, and then we can see something here. These ones are very, very high: Mombasa and Nairobi. As I said, I was surprised with the other one. Now this one I was not that surprised, though I'm not seeing Nakuru, but Mombasa and Nairobi are very, very high. They are an extra like 60 crimes per 10 kilometers squared in Nairobi, and compared to Kisii, which is number 3, and an extra like more than 80 crimes per 10 kilometers squared compared to the number 3 to Mombasa. And I wrote something here. This is a more understandable graph. Some typing error, no problem. Being the oldest cities in Kenya, Nairobi and Mombasa have a very high crime rate per kilometer squared. This is mostly this is actually per 10 kilometers squared, but no problem. This is mostly attributed to the city life of crime. Also, people are used to Nairobi crimes, but be aware the next time you think of holiday destinations and Mombasa is in your plans. Unless you really know the town, avoid it. Opt for Kilifi. As you can see below, it has a very low at just 1.5 crime per 10 kilometers squared compared to Mombasa, which has more than 100 crimes per 10 kilometers squared. Then we just do a small calculation here of Kilifi. You can see Kilifi is just 1.4. So if you're going to the coast, think about Kilifi, don't think about Mombasa. Mombasa has more than 100. Kilifi has just 1.5 crimes per 10 kilometers squared. So it is more than 100 times, almost 100 times more crimes in Mombasa than in Kilifi. Bank possession cases distribution. This one we just check on the bank possession cases per 10,000 people. Use the same concept of creating a distribution here. I used pop distribution this time. Created a variable, I used it here, and then just creating that new column, which is the last one here. You can see it, and then creating a graph for them. You can see the Rakanithi and Murang'a. The Rakanithi and Murang'a have a highest number of persons per 10,000 people with a bank possession case. You can see that it's an extra person in the Rakanithi and an extra 1.0 something of a person. So per 10,000 people, an extra possession case. And possession are the ones that have been caught. They are actually people who are not caught, so that must also be reflective. Then per 10,000 kilometers, 10 kilometers squared, we do the same thing. Create a column, then create a visualization, and when you look at this visualization here, you can see Mombasa is very, 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 very high. And I had something about that. I just wrote that Mombasa is surely the Wajakoya town. It's more than doubles the second on the list in the number of bank possession cases per square kilometer, or square 10 kilometers squared. You can see this is just less than 3 here, 2.5 maybe, but more than doubles Nairobi. So Mombasa is very, very marijuana oriented. Now let's go to correlation. we just want to check on the correlation of bank possession to crime. First, a little about correlation interpretation. So a correlation of 1.0 indicates a perfectly negative correlation, and a correlation of 1.0, and a negative shows a negative correlation, a positive shows a positive correlation. If the correlation coefficient is greater than 0, it is a positive correlation. Conversely, if the value is less than 0, it's a negative correlation. Positive correlation is measured on a 1.0 to 1 scale. On a 0.1 to 1 scale, weak positive correlation will range from 0.1 to 0.3, moderate is 0.3 to 0.5, and a strong correlation is 0.6 to 1. The stronger the positive correlation, the more likely the stocks are to move in the same direction, or the more the correlation, the more they are likely to move in the same direction. So if there's a big correlation between A and B, means the more A rises, the more likely B will rise too. And that's basically what correlation is. So we just take on correlation of bank possession cases to total crime per 10,000 people, and you can see a 0.6 correlation here, and I have written something here which is with a correlation of 0.65, there's a strong correlation on crime per 10,000 people to the cases of bank possession per 10,000 people. Then we can check on the correlation of bank possession cases to a total crime rate per 10,000 kilometers squared. So this is bank per 10,000 kilometers squared and total crime rate per 10,000 kilometers squared. We check the correlation, and the correlation is 0.9, which is extremely high. So we can see this is supposed to go down. So you can see with a correlation of 0.9, there is a very strong correlation of crime per 10 kilometers squared to cases of bank possession cases per 10 kilometers squared, and correlation of bank now to possession cases totals. We use the totals here, and you can see also the correlation is very, very high. With a correlation of 0.7, there's a rather strong correlation of total crime to cases to bank possession cases. Okay, now we have seen the correlation, which is very high actually, and I think it's because bang is illegal, and the people who are caught possessing bang, though most of them will be doing it maybe for leisure purposes or pleasure, most of them are doing a criminal activity, and criminal activities are coinciding with crime, total crime. Having possessing bang, however, whatever the reason, is a criminal activity, and a criminal activity is correlating with other criminal activities. Okay, let's look now at regression analysis of bank possession to crime. First, about a little about regression. However, while causality and correlation can exist at the same time, you can see correlation up here. I'm saying, however, while causality and correlation can exist at the same time, correlation does not imply causation. Causation is basically A causing B. As you can see here, causation explicitly applies to cases where action A causes outcome B. On the other hand, correlation is simply a relationship. Action A relates to action B, but one event doesn't necessarily cause the other event to happen. Therefore, let's look at regression, which is a better metric for causation. Let's see if there's any causation between bang and crime. We've seen that there's a strong correlation, but let's see if there's any causation. First, we check the distribution of the variables. We just check on the general distribution using Seaborn. Check on the distribution. You can see this is a normal distribution, but skewed towards the left. The distribution is very skewed. For a proper regression analysis, we'll have to transform it using logs. We can also see that the bang distribution is also very skewed. We need to transform it for proper regression analysis. We need to transform it using logs. So by using logs, we transform this data and make it a little bit normal, the normal Bell distribution, which is not skewed. So by doing this, we have to create another variable, which will be the log of bang, which will just use numpy to create a log of bang. Then we also use get a log of the grand total crime using numpy and using the log functionality to get the log of this. And then now we can check on the distribution. If we check on the distribution of the log of bang, we can see now it's way normal than when it was. And then if you check on the distribution of the log of the total crime, is now normal, and now we can undertake our regression analysis. Now that we have a normalized all our skewed graphs using logarithmic methods, now we undertake the regression. Regressing total bank possession cases with total. I use this again column so that I can see the names perfectly and copy paste them. And when we regress using the joint plot, we just take the data as the county data, x as log, y as log of grand total, and then kind right reg, which is just basically regression. We can see this regression curve. This regression line shows a positive regression relationship between bang and the total crime. If it looked something like this, it will be negative, but since it's going up, since when the log is going up, the log of bang is also going up, it shows a positive regression. But now let's use scikit-learn linear model to see if we can predict total crime using bang cases. How this works, we'll just have an x, which will be the county info. We'll take the log, and the y will be the grand total crime. The x is the predictor variable, the y is the variable to be predicted. I used to numpy because if I don't use this, it brings an error. X does not have a valid feature name, but isolation forest was fitted with feature names warning. This is a warning, so you just use to numpy, and that warning disappears. So when you run this, we then create a variable called the regression, which uses the linear model.linear regression from the scikit-learn. Then we fit this x and y on our linear regression line, and then when we fit it, now we can use it to create how will I put this? We can use it to create our predictor variable. I then proceeded to just creating a function. As you can see here, we are going to use np.exp, which will be here. np.exp. We can also you can also see round, which is .round here to round them to different decimal places, and this is used. np.exp is used to help us reverse the algorithm, the logarithm expression, because you remember we used log of bang, so we have to reverse it to actual values rather than just having log predicting the log of bang predicting the log of grand total, just so that we can have bang predicting grand total crime. I created a function here which I called the number of crime cases, number of marijuana cases, which passes in bang cases, and then these bang cases will be np.log of bang cases, so that it can convert it to a log, and then this n itself will be the variable that will be passed, which is the number of bang cases. Later on, this n will be converted back using this expression, so that we can know the number of cases exactly. Then we'll just print for that value marijuana possession cases leads to this number of total crime cases. And then when we just run this and pass in the number of bang cases, like let's say 120, run this, we'll have a 120 marijuana possession cases leads to a 2023 total crime rates, 2023 total crime rate. This data has some resemblance to the data itself as seen below. You can see we can just see when it gets to 100 and something, you can see 2227, which kind of looks like this. When you go maybe to 150, it increases, and it kind of looks like a very good predictor, though we have not tested it, because if we had data for 2019 and then we used it to we had data for 2018, used it to train using 2019 data, then using the 2019 data to train the 2020 data, then using the 2020 data to predict the 2021 data. That will be a trained model, which will be way better. But for this, since we just have the 2020 data, we just have to settle with that. We'll just clean it once they have removed the 2021 report and train it, so that it becomes a better predictor. But that is what we have for now. Okay. Thank you for getting to the end. This that is passed here, this was just used for explaining the beginning of the video. We don't have to have all this. We can just have this, and then we can just see our prediction here. 130, let's say 200. You can see marijuana possession cases leads to 2614 total crime cases, and that's how we create that predictor model. We can see a lot of exploration data, exploratory EDA, data analysis, which is very important in this. I've just forgotten my how to say EDA. I'll just use EDA. Let me just go up there and just see how to say it. Exploratory, yeah, a lot of exploratory data, and you have learned so much about the crime. We have seen how to merge this data. We have seen how to leverage, do just simple data scraping with pandas, and we have learned how to use Seaborn to do some visualization. I hope this was educative, and this is a very good portfolio project to add to your portfolio. Thank you very much for participating in this with me. Thank you very much. If you have reached the end, you're a genius. You're the best. Thank you very much for watching. See you in the next one. Okay, before I finish, let's go back to the regression analysis of bank possession to crime. We remember we checked on the distribution plot of the grand total crime, and also on bank. I also checked on area in kilometers squared, which is also skewed, and I also checked on the population, the 2019 census, which was also skewed. I also proceeded to adding these two logs of the area and the log of the population, and when you look at them, they are more or less normal, and now I used both of them to help me in the prediction. When we go down to the X and Y here for our linear model, linear regression predictor model, I added a couple of things on X, which from log of bank which you had, then I added log of area and I added log of population, and these two parameters will also be used to help us in the prediction of the grand total crime. I added them here, and when you check here, I added in my function here, I added bank cases, area, and population. Remember, it was just one, and now I said N was the bank cases, A was the log of the area, and B was the log of the population. And then I added these predictors, which was just N. I added A and B, which were just area and population, and then I changed the statement to be marijuana possession cases in a certain area of kilometer squared. That area with a population of that will lead now to total crime that. And when we run it here, you can see that 41 marijuana possession cases in 35,376 kilometer square radius. Or let me just rename it to area, kilometer square area. Kilometer square area with a population of 315,953 people leads to 467 total crime cases. And this is just when you look at also this data, resemblance of the data itself, it shows some resemblance when you look at bank, area, and population here, and crime. you can see it kind of helps us more. Okay, thank you. This also we can I changed a couple of parameters here. We can use them and see that 100 marijuana possession cases in a 250 kilometer squared area with a population of 20,000 people leads to 1,152 total crime cases, and that's how the predictor model works. This was the last portion of the video. I hope you watched it till here. Thank you very much for finishing the video. Yeah, you're a genius, just like I said before. Adios, have a great rest of your day, and let's learn together.